will you just leave the problem as is? All right, the next one is identify the vertex via completing the square. So the obvious way would just take the b divided by 2 squared. But most students forget that. They don't understand why it comes from. And typically we would go through a whole lesson explaining that process. So what I'm going to do is I'm going to say, what if the problem looked like this? Y equals x squared plus 8x plus 16. And what if I said, find the vertex here? Well, hopefully you'd recognize that if we wanted to find the vertex, then if we had it in vertex form, x minus h squared plus k, then the vertex would be h comma k, right? So if I could rewrite this as a binomial squared, right, and factor this, and actually this is factorable, into x plus 4 squared, right? And therefore you could say k would be like 0. So now you could see that the vertex in this case would be negative 4, 0. But the whole point that I'm trying to bring to you is this is factorable. This is factorable into a binomial squared. So typically what we can do here is I'm actually going to create this, so therefore I can factor it. Now again, it's really important though that you understand, you just can't like add a 16 to a problem, right? So that's me explaining this is what I want. But again, this one doesn't have a 16, it has a 10 here, right? So what we're gonna do is we're gonna say, all right, I know x squared plus 8x plus 16 gives me a binomial squared, right? But I still have this 10 here. And then also, you just can't add a 16 to an equation, so therefore we're going to subtract a 16 on the outside of the equation. So again, when I add a 16 and subtract a 16, those undo each other, right? So if I took those away, I would have my original equation. But now, if I add and subtract on the same side, now all I'm doing is I'm just doing some magic with my grouping. I am going to group this perfect square trinomial because it is factorable into x plus 4 squared, and then 10 minus 6 is going to be a negative 6, and therefore the vertex here is negative 4, negative 6. So not something that I really teach, that way, but hopefully for this live stream that kind of gives you a little bit of idea. You could also use the a squared plus bx plus c, so therefore b divided by 2 squared, and that's the number you add inside. But again, like if you already know what the perfect square trinomial is, like 8 divided by 2 is 4, 4 squared is 16. That's what you add and subtract inside of there anyway. So hopefully that kind of helped. It's a good method when you have something that is fairly basic for a perfect square trinomial. Obviously, once you start getting into like fractions or numbers that are a little bit more difficult, that might not be as straightforward. So therefore, that's why we a lot of times rely on the b divided by 2